This video lecture is about descriptive statistics for quantitative variable using visualization approach. The diagram shown in the slide provides some guideline for the visualization presentation according to different data type and data structure. Let's focus on quantitative data type. If you still remember, the data structure for quantitative can be cross-sectional and time series. Suitable visualization for summarize the descriptive statistics on time series data is line graph, while suitable visualization for summarize the descriptive statistics on cross-sectional data is tables, including frequency distribution table, relative frequency distribution table, cumulative relative frequency distribution table, and joint frequency distribution table. For charts and graph, suitable charts are histogram, stem and leaf, scattered diagram, ogive, and also box plot. In the next slide, we will investigate all these visualizations. Look at this problem. Let's say I have data set that represent the number of customers arrive at restaurant in 15-minute intervals. In total, the observation is 40 randomly 15-minute intervals. With this data, is it possible to use frequency table to describe the data? The answer is yes. This is the frequency table generated for this data. From this table, we can see that using frequency table, the number will be in sequence. Instead of we can count the frequency for each of the number of customers, we can also count the relative frequency. Relative frequency can be expressed as a fraction, a decimal, or a percentage. Next, let's say I want to make a comparison between two sample groups about years of college for Dallas and Knoxville. Data given for this problem is the frequency table of years college. With this presentation, can we make direct comparison to summarize years of college for these two cities? The answer is no. We cannot make summary by directly compare one to one. This is because the two cities is not having same total of observation. Therefore, what you need to do is to calculate the relative frequency for each of years of college for these two cities. This is the useful of relative frequency, whereby it can be used to compare the frequencies of different values or categories across data sets that have different sizes or scales. This is the relative frequency generated for the Dallas and Knoxville problem. After the relative frequency is counted, then the summary on the descriptive is Knoxville has relatively more people without any college, which is 56.7%, or with 1 year of college, which is 18.8% than Dallas, that is 21.9% and 13.1%. At all other levels of education, Dallas has relatively more people than Knoxville. Next, let's consider this dataset presentation. This data is about the time which is in second, for emergency response for 72 cities. In this data set, it is noticed that the minimum time, which is in second, to communicate to this communication system is 35 seconds, and the maximum time to communicate is 1,492 seconds. The range of minimum value and the maximum value is too broad. With this situation, can we do the summarization and exploration of descriptive statistics based on frequency table? The answer is no, because if we still want to use frequency table to describe this data, our frequency table will be very lengthy and it difficult to summarize. Therefore, the suitable visualization is using joint frequency table. SPSS can generate the joint frequency table by using function transform and binning. The tutorial for this will be shown during the virtual class, or you can follow the steps shown in the slide. The dataset that we will use is respond.sav, which you can download it in the GitHub, and I have also shared the link in the ice-breaking session and in the e-learning platform. In addition, I will also share a YouTube video about constructing joint frequency table using SPSS. This is the continuation for the steps to construct joint frequency table. Finally, after binning, then we can construct the joint frequency table. The next part, we will learn other visual presentation for quantitative data type. Firstly, histogram. A histogram is a visual presentation of the distributions of data. It consists of adjacent rectangular bars where the width of each bar represents a range of values and the height of the bar represents the frequency or the data. They look almost exactly like a bar graph, so it's easy to get confused. Therefore, what is the differences between histogram and bar chart? Shown in this diagram or slide is the differences between histogram and the bar chart. The major difference between bar chart and histogram is the bars of the bar chart are not just next to each other. In the histogram, the bars are adjacent to each other. In statistics, bar charts and histograms are important for expressing a huge or big number of data. The similarity between bar chart and histogram is both are pictorial representations of grouped data. Next, shown here is line graph. Line graphs are used to track changes over short and long periods of time. Therefore, if your quantitative data is having a structure of time series, line graph is a suitable presentation of visual. Line graph can also be used to compare changes over the same period for more than one group. This is the example of multiple line graph generated by SPSS. Look for the additional video on how to generate line graph using SPSS. Another visual presentation which is suitable for quantitative data in descriptive statistics is scatter plot. A scatter plot is also called a scatter chart, scattergram, or scatter plot XY graph. The position of each dot on the horizontal and vertical axis indicates value for an individual data point. It presents the relationships between two variables in the dataset. It represents also a data points on a two-dimensional plane. Both variables are quantitative for scatter plot. Next visual presentations for quantitative data is box plot. Box plot, also called as box and whiskers plot, is a very popular and widely used plot for visualizing data in the field of statistics. Box plot displays the distributions of data based on a 5-number summary. There are minimum value, lower quartile, median, upper quartile, and maximum value. These numbers are labeled on the box plot shown in the diagram. The whiskers represent high and low reference values for excluding the outliers value. Box plot is often used to show the distribution of numerical data along with the symmetry and skewness of the data. Beyond the whiskers, individual data points with a dot shows values vary significantly away from typical values within your dataset. This is the example of box plot generated by SPSS. Look for additional video on how to generate box plot using SPSS. Using visualization approach in descriptive statistics for quantitative data, in terms of central tendency, those visuals can be used which are box plot from quartile to value, frequency table from the greater or lesser count, and histogram from the center value of the chart. In terms of positions or the locations of the data, box plot is visual which best describe about the positions or locations of the data. This is through the quartiles, maximum, minimum, and IQR or interquartile range. For the variability or the dispersions on the data, many charts can be used to visualize the variability, for instance, histogram, box plot, and scatter plot. And lastly, to describe and explore on the shape of distributions of the data set, visualizations that can use for quantitative data type are histogram, which is through the pattern of histogram, and also the box plot through the size of the box and the placement of the quartiles. So far, we have finished cover on the topic of visualization approach in descriptive statistics for qualitative and quantitative data type. We will continue our journey in learning about descriptive statistics for these both type of data. This time, we will learn about numerical measurement approach. Please watch the next video. Thank you for listening.